Hi everyone, a warm welcome to all who joined for this webinar here. First of all, appreciation to you all in stepping forward to make this lockdown period a productive one, being at home by learning. So, we all undoubtedly remember the year 2020 as the year of pandemic, but for the people like us who join here, the engineers, engineering professionals, even for the healthcare people, this year is taking another phase, that is, I would say, 3D printing year. Yeah, though 3D printing industry is in existence for a long time, this field in recent days has made manufacturing more accessible for the common man. I hope you all will agree with me. Yeah, as we know right now, around the world, 3D printing in a common man eye is a stopgap supply chain solution for PPE and other needful products for this pandemic phase. So, we Insta3D Technologies, as a trusted partner by several leading manufacturers, groundbreaking designers, makers, thinkers, we always focused on spreading awareness about the technology and help Indian engineering to gain more knowledge. We Insta3D Technologies is fueling the next generation projects of innovation through our work in various fields which include automotive, industries, medical field, architecture, engineering and education. Being a successful enterprise in this field, we focus on proactive and creative learning process. Well, we have framed this session in that way. Let's get into the session now.
3D printing is still a very new technology and which is not readily available to an average consumer. It has that wow factor which can engage students who would otherwise have nothing to do with their learning. Moreover, using 3D printing in the classroom will allow the students to become a part of the growing online community dedicated to 3D printing. The greatest advantage about 3D printing is that it makes everything hands-on. Let it be learning about physics or math concepts. Designing and printing a model of your prototypes, learning about structures, anything is made hands-on with 3D printing. Hence, 3D printing is a technology which can actually empower students. So, what is design thinking? Is it about creativity, or is it about designing, designers, or is it a process? Let's have a look. Over recent decades, it has become crucial to develop and refine skills which allow us to understand and act on rapid changes in our environment and behavior. The world has become increasingly interconnected and complex, and design thinking offers a mean to grapple with all this change in a more human-centric manner. If you look onto the stages in design thinking, stage 1 is empathizing, which is basically researching your user's needs. This first stage of the design thinking process allows you to gain an empathetic understanding of the problem you are trying to solve, typically through user research. Empathy is crucial to a human-centered design process like design thinking because it allows you to set aside your own assumptions about the world and gain real insight into the users and their needs. The stage 2 is define, which is stating your users' needs and problems. In the define stage, you accumulate the information you created and gathered during the empathize stage. You analyze your observations and synthesize them to define the core problems you and your team have identified so far. You should always seek to define the problem statement in a human-centered manner, so you do this. Moving on to this third stage, which is ideate, which is again challenge, assumptions, and then creating ideas. Designers are ready to generate ideas as they reach the third stage of design thinking. The solid background of knowledge from the first two phases means that you can start to think outside the box. You look for alternative ways to view the problem and identify innovative solutions to the problem statement you have created in the first two stages. In the stage 4, which is called prototype, you are starting to create solutions. Now, this is an experimental phase, and the aim is to identify the best possible solution for each of the problems identified during the first three stages. Design teams will produce a number of inexpensive, scaled down versions of the product to investigate the problem solutions generated in the previous stages. Now, the last stage is the implementation stage or the testing stage. Now, in this stage, you try the solutions you have created. Designers or evaluators rigorously test the complete product using the best solutions identified in the prototype phase. Now, this is the final phase of the model, but in an iterative process such as design thinking, the results generated are often used to redefine one or more further problems. Now, I would like to invite Mr. Joseph Matthew, Managing Director, Insta3D Technologies, for sharing his views on 3D printing, an innovative tool to empower students.
Hi everyone, we welcome you all to this webinar on 3D printing, an innovative tool to empower students. We Insta3D is a firm involving engineers, creators, makers, and we work as a team with the aim of reaching 3D printing technology to everyone. Briefly, we support colleges, industries, and various startups to set up 3D printers and other accessories, provide complete training so that they can excel in their career. InSeed. It's a digital transformation platform from Insta3D Technologies where one can gain knowledge on 3D printing technologies available, newer versions of 3D printers, and its accessories. This webinar in particular is meant to explain how 3D printing acts as an innovative tool to empower students. Firstly, I would like to mention every student is creative and their creativity is hidden in them. It can be shown only through a tool, and I would say 3D printing is such a tool to support every student. For example, a student doing their project can rely on 3D printing technology to bring their ideas to life. If we see institutes abroad, they have started implementing 3D printers in their classrooms, which makes every student to involve in a practical learning approach, and it enhances their creativity and knowledge. In today's outcome-based curriculum approach, to enhance your problem-solving skills, I would say start 3D printing now and experience the different dimensions of creativity. First, we are going to look on the basic types of 3D printing. Additive manufacturing or 3D printing technology lowers costs, saves time, and extends the limit of fabrication processes for product development. Over the last few years, high resolution 3D printers have become more affordable, easier to use, and more reliable. As a result, 3D printing technology is now accessible to more businesses, but choosing between the various competing 3D printing solutions can be difficult. So, which technology is suitable for your particular application? What materials are available? What equipment and training do you need to get started? How about the cost and return on investment? In this slide, we will take a closer look at the four most established plastic 3D printing processes today. First one is FDM, which is called Fused Deposition Modeling. So this FDM is also known as Fused Filament Fabrication, which is the most widely used form of 3D printing at the consumer level, and it is fueled by the emergence of many hobbyist 3D printers. This FDM 3D printer builds parts by melting and extruding thermoplastic filament from a printer nozzle and depositing it layer by layer in the build area. FDM works with a range of standard thermoplastics such as ABS, PLA, and their various blends. The pros of FDM 3D printing: it is very fast, low cost consumer machines and materials can be availed. The disadvantages of FDM is its low accuracy, lower detailing, and limited design compatibility. Whereas the applications of FDM is you can show the basic proof of concept to the higher management or your clients, and you can produce low cost rapid prototyped models. So the second technology is stereolithography. This was the world's first 3D printing technology, invented in the early 1980s, and is still one of the most popular technology for professionals because it has the highest resolution and accuracy. The clearest details can be made out of a SLA machine. This SLA resin 3D printer uses a laser to cure liquid resin into hardened plastic, which is a process called photopolymerization. SLA is a great option for highly detailed prototypes that require tight tolerances and smooth surfaces, which is required to make molds, patterns, and functional parts. The main pros of SLA machines are it's of great value and it's of higher accuracy, smooth surface finish components can be produced, and a range of functional applications is being done out of a SLA machine. The cons of SLA machine. It is sensitive to long exposure, and the main applications of SLA is functional prototyping, making patterns, molds and tooling, dental applications, jewelry prototyping and investment casting, and model making. Next is selective laser sintering, SLS. SLS 3D printers use a high powered laser to fuse small particles of polymer powder. The unfused powder supports the part during printing and it eliminates the need for dedicated support structures. This makes the SLS ideal for complex geometries, and it can do anything which including interior features, undercuts, thin walls and many negative features. Parts produced with SLS printing have excellent mechanical characteristics with strength resembling that of injection molded parts. The most common material used is nylon, and nylon is a lightweight material, strong and flexible. As well as it is stable against impact, chemicals, heat, UV light as well as dirt. The pros of SLS technology is that it can produce strong functional parts and the design freedom is available. No need for support structures is the most important advantage of using SLS technology, so that you can get a good surface finish without support structures. The disadvantage of SLS is this: rough surface finish is available and it has limited material options. The applications of SLS, it can be used in functional prototyping, short run businesses or custom manufacturing. Next is the DMLS, direct metal laser sintering, which is one of the very few 3D printing technologies that can create directly a metal part from its 3D computer model. This is an advancement of powder metallurgy, which uses heat and pressure to form powdered metal parts. The working material of this 3D printing process is mainly powdered metal, and it is of the sizes 20 to 40 micrometers. Smaller metal particle size and less variation allow it to get a better resolution out of it. So the main advantages of using DMLS is direct metal printing is possible, a variety of materials can be used, strong and functional parts can be produced, and it's recyclable. The disadvantage is its high price and the porous elements which is available in the 3D prints. Less build volumes are only available in this DMLS technology. The applications of DMLS is you can make custom prosthetics, medical titanium bone implants, dentistry crowns, bridges, etc., which is printed in cobalt chrome. It's very strong in nature. And DMLS is a key part of reducing part count, creating complex geometries, and weight reduction. These parts are used in commercial aircrafts and rockets, where reducing part counts accounts to a huge huge cost reduction. Next one is finishing 3D prints. So once you 3D print a component using any of the technologies available, the most important part is post processing, which is finishing the 3D prints. It involves removal of support structures, sanding, finishing it with many chemicals available in the market, painting, etc. So once the 3D print is done, you'll be removing it out of the 3D printer, build plate, and you will be proceeding it with the removal of support structures. So basically there are two types of support structures available. One is breakaway support structures and the other one is water soluble support structures. So what is breakaway support structures? When you manufacture a component in FDM machine, you'll use two raw materials. One will be the part building raw material and the other one will be the support material. So when you use the support material same as the part building raw material, these BAS materials can be formed. BAS in the sense breakaway support structures. So you can just break away the support structures formed in the final 3D printed product. Whereas you can also use water soluble support structures, like the material used for this water soluble support structure is PVA material, and when dipped in hot water, this water soluble support structure dissolves in the water and the final output is obtained. The next finishing of 3D print is via sanding. You can use any sandpaper, grit paper to finish the 3D printed components. So when you compare the materials used in FDM technology, ABS is more easier to finish, whereas PLA is bit difficult to finish. And the next is finishing with the epoxy chemicals or XTC 3D material. In this, you can coat the 3D printed part with epoxy or any chemicals available in the market so that you can get a glossy surface finish. Next post processing technique is painting. Generally, people use acrylic paints or any automotive paints available in the market in order to finish the 3D prints. Next, we are going to look at advanced 3D printing methods. The first one is bioprinting, which is an additive manufacturing process where biomaterials such as cell and few growth factors are combined to create tissue-like structures that imitate natural tissues. This technology uses a material called bioink to create these structures in a layer by layer manner. The technique is widely applicable in the fields of medicine and bioengineering. Recently, the technology has even made advancements in the production of cartilage tissue for use in reconstruction and regeneration. So, this bioprinting works in a similar way to conventional 3D printing methods, where this bioink or living cell suspension is used instead of thermoplastics. The basic steps in bioprinting involves 3D imaging, that is getting the DICOM files from the CT scan or MRI scan data available. And next is 3D modeling, converting these scan data into a 3D model, STL file. Then comes the bioink preparation, where these structures are created and it is inputted into the bioprinter. The printing happens and then the solidification occurs. The final output of living cell suspension is obtained. One of the best example for this is testing treatment for diseases using artificially affected tissues. They also used in drug testing and clinical trials. They have a great potential actually. For example, to drastically reduce the need for animal trials and organ donation, transplantation, which are the most best applications of bioprinting. You can also use bioprinting for cosmetic surgery and tissue regeneration. Next is 3D printing in construction industry. In the construction industry, 3D printing can be used to create construction components or to print entire buildings. In this construction 3D printing, it allows much faster and more accurate construction of complex items, as well as it lowers labor cost and produces very less waste. It might also be able to enable construction to be undertaken in harsh or even dangerous environments not suitable for a human workforce, such as in space. So, clearly, all of these projects have enormous potential. There are questions about how construction 3D printing can be integrated with other building components, on how they incorporate services and reinforcement. But I say, in the long term, they should be better, faster, and perhaps low cost buildings can be produced using 3D printers.
Now, in this webinar, we shall be discussing a case study where an idea has been taken to the final product. Before we discuss on that, we need to know which are the stages of prototyping. Hence, these stages are understanding the objective, sketching the concept, deciding, and then going for the prototype, and finally validating the functionality. You can easily turn your design into a 3D visual object. Conventional customers are boss at exchanging views on improvements. Discover the benefits of 3D printing. Most companies still order 3D objects the traditional way. However, this process takes a long time and they cost a lot of money. From choosing the best manufacturer to the ordering process, waiting for the production until distribution, and after weeks, the ordered object is delivered and it can be finally used. You can forget all about this long traditional ordering process because with a 3D printer, it doesn't take weeks but it takes hours. And how does this work? First, a design is created. The software makes printable layers. The 3D printer stacks the layer on top of the other and it's all ready to use. Customers can exchange views on prototypes, make that one custom-made component, and you can assure your customer that they are getting their models in a matter of hours. let's get to know more about INSEED. INSEED is the training vertical of Insta3D Technologies. Due to the COVID-19 pandemic, social distancing, cancellation of regular academic activities, meetings, events, students and faculties are finding it increasingly difficult to obtain access to continuing education and training. In response to this need, INSEED has been offering access to online training for students, professionals, and faculties. The online training include webinar, certification courses, e-learning series, placement programs, and faculty development program. By opting for these programs, they would be able to learn new skills as well as earn certificates. On behalf of Insta3D Technologies and the entire team together, extend a very hearty vote of thanks to all of you for giving us your precious time and being a wonderful audience throughout. Thanking you and have a great day.